welcome to Make It Easy. So today we are going to discuss another important question that has been asked again and again in an SD1 interview of many companies. So in this 2020 SD1 interview in Amazon, they have asked this question: LRU कैसे design? So basically, this question is pretty easy and appears, but when the interview suddenly asks you to write the code, then it's just you were just stuck how to write that much long code. And sometimes when you try to use some kind of STL and interview interrupt in the middle and see that no, you have to not use any type of STL, and you just got stuck. Because and also when we are going to implement this LRU case, we have to use some kind of data structures, and to implement them, and there always we miss some points. And if it is also your machine coding around, then you just got fuck up, because you have to implement whole and then you got null pointer exception and all those things. So for this I'm going to discuss this question in very logical manner and very easy manner. Our goal is with Make It Easy is to make these things quite easy. So we will discuss this question, LRU कैसे, and this is a very important question. One thing is you have to know the concept and then how you should write it logically inside the interview. Okay, so let's start. So this is a statement from LRU कैसे. So I will try to make it little bit easier for you to guess. Okay, so this is a statement, and don't see the code. First, there is okay. So we have to implement LRU case. So the class should have three methods: get, set. Okay, two methods: get and set. Get x means return the value of x if key exists in the case. Otherwise, it should return -1. And simply as set x y, we insert the value x if it is or not represent if case. And this thing is here. So what in simple case, like hash map or hash set, what we done just uh, for any key we insert it and there is corresponding value against this. But what happens in actual cache? Cache is not of unlimited size. Cache has some fixed size because it uses some kind of RAM. So what we have to have a constraint is that caches always have a limited size or fixed capacity. So each and then cache uses several kind of algorithms to make remain this cache size to that much capacity always. So one of the algorithm is LRU cache. LRU cache is least recently used, and this is widely used in many kind of operating systems, and that's why it is amazing question. So you have this set operation set xy, and every time the capacity is a max capacity, you have to eliminate the least recently used element, which is the least recently used key, means the key which has been not accessed from a longer time. So means suppose on a key, if there is set operation or get operation has been performed, then that key has been used in recent. But we have to find the key which has not been used for a long time. That's what we want. And okay, so let's start with cache. So okay, I have to start with this. So what you happens in actually in cache, you have kind of map. uh, what in map there you can have some keys like 1, 2, 3, and then suppose values are 6, 7, 8. So these are the key and these are the values, and now you have to implement this thing. Okay, so what happens in this hash map, if there are again keys come again and again, you just insert them with no limit on capacity. That's what hash map do. So we use one hash map. So in hash map, operation correspond to only complexity. You have to insert and look up. So it is constant of one operation, because we can hash a value. You have given any value, we can hash it. This is also another important question. Many times in interview they ask you to implement whole hash table, means you have to design your own hash table. And this is also an important question, and this has been asked to me in my Amazon interview, and I just got stuck because I have to implement the whole data structure of festival, and this is quite lengthy and cumbersome, and you have to implement all in 40 minutes of interview, and even in a return. So that's quite cumbersome. We will discuss this also in some other tutorials. So let's say this is has table to you, and you have to, and this has complexity of figure of 1 to insert any element and to fetch any element, because simply you have, if you want to insert some key, then you will first find it has value, and just due to this has value you can find the value associated with. So this is simple hash table. But what we want the when this hash table reaches some capacity, suppose max capacity is 2. So first set operation will perform, second set operation will perform, but when we want to perform a third set operation, then this time we have to eliminate of one key, means we have to find a least recently used key and we have to eliminate that key. That's what least recently used is. So for this purpose only we have to come with some logic. So what we the logic is, we use a doubly linked list. Doubly linked list is a kind of here queue which uh, prioritize the element based on the recent useness or usefulness of them. So each node in the linked list corresponds to a key, and each node contains key value and next pointer and previous pointer. So this way we have given keys. So what happens, so when first node comes, we will insert that in the linked list, and 1 and corresponding is 6. What happened, when a second key is 2 and 7 comes, we will attach it in the front of this means this is recently used one, means 2 7 has been recently used over 1 6. Now when 3 8 comes and our max capacity is 2, so we know that the maximum capacity can be 2, so we have to remove one of the element. So this is a front and this is a rear, so we can remove a rear part, and removing this, then we have to insert this key. Since this is recently used, so we will insert it in the front of the linked list. So this is only importance is here of doubly linked list, means how doubly linked list just in big O of 1 has given us uh, uh, least recently uh, used element, because rear element is always a least recently used and front element is a recently used, is most recently used. So front element and the linked list is the most recently used, and last element is at least recently used. Also here in hash table we do not contain a value for that particular this, we store a node address in the hash table. So whenever a key comes, we first check it in hash table. If there is one address, then we go from this pointer we go to this linked list address. So this way this lookup in the linked list is of big O of 1. This is simple. Now we have to discuss a second scenario. So for that I have to start another drawing, and suppose you have a table with some keys 1, 2, and 1 and 2. Suppose max capacity is 2, and this contains address, means first there has been insertion of 1, and then there, so this will contain the pointer to this, and then there is insertion of double linked list, and there is insertion of 2. So this is a front, means most recently used, and this is a rear, means less recently used. So whenever we want to evict a cache by one element, we just pick up our least rear part and evict that element from the hash table, and this is just simply delete it from here and evict it from here. But what happened when a gate operation perform on any key? At this time, when get is performed, suppose after performing of, let's say suppose operation perform first is set 1 with some value 6, and then set 2 with some value 7. Now again, so the so set 1 6 is first element friend, then again set 2 7 is become friend, and this become rear. But now again get 1 has been performed, get 1 and so since get 1 is performed, so now this is become 1 should come in the front because this is now most recently used. So what we do, whenever a get operation or a set operation is performed on already existing a key, then at that time we have to first detach that node from its pointer, from its linked list, and then move that linked list to the front. This is what all we want. First we want to detach a node, and then we want to insert it in a front. So that's it. And now we go to code. Little bit see the code. So we have designed a LRU cache, and okay, so I will create a repository on GitHub where all these my code snippet will be available, because these code are a little bit logical, so that's why I want them. You should go through them if you like it. So basically this is a code. See here, I haven't used any STL because in interview they most probably they will ask you to write the whole code because they want it. uh, because they want to check your abilities, whether you can write a maintainable logical code or not, whenever you can write this much long code or not sometimes. So this is sometimes they will check you. Most probably if you explain well, then they might not check you, but for at least one question they will ask you to write whole code to check your coding abilities. So this is it. You have a node which is a mainly a node of linked list, so it has key, value, previous pointer and next pointer. Since we are using this auxiliary data structure to support LRU, so we are using double linked list for that. So there are two pointer, previous pointer and then next pointer. So this is constructor with key and value. This is whole node string. In this LRU cache, we have one front pointer which point to front, and then we have a rear pointer which point to rear, and then simply we have unordered map which have of type which has key as int and value as a node star. So this is a hash table. So this key is a int, and this is a node star. This is node star. This node star will point to the corresponding pointer in the linked list. uh, and this we call cache. Was what is because simply an order map is of unlimited size means you can insert any number of element in the cache. Actually, you cannot insert because there are RAM constant, and if you try to insert more than a million elements inside the cache, then automatically your RAM goes up and you will get a segmentation fault or all those things. But okay, there is a max capacity, so we have to. I have these are some mi internal functions which I use for this two things, get and set thing. So there is LRU cache with int capacity. So this is your constructor. So initially in the linked list we have front is null, rear is null, and max capacity we can have of capacity. For now that's two. Let's say, and this is first function int get int key. So in this, what happens in the get function? What we will do in get function, whenever a get operation encountered, what we will do, we will find it in cache key. If the element is not present in cache itself, then just we return it -1. That's it. But if element is present in cache, then we will find a pointer to that particular node from this hash table, and then what we will do, before returning that value from that node, we have to do one more thing. What? Because on then link the gate operation has been performed, so we have to move that node to the front. So how we can move a already present node in the double linked list to the front? So for that, what we will do? First, we will do detach a node. Means we will detach this node from a double linked list. Means what detach function do? Suppose there is three node in the double linked list, and what we will do? If get operation has been performed on this one key, suppose get operation has been performed and this key is present inside the hash table, so you have to look up for this pointer from here, and now we have to detach this because this is now most recently used a linked list node, so we have to move this to the front. So if we have to move this node to the front, first we have to detach that node from here. So for detaching this node, what we have to move, there is next pointer, and uh, uh, we will see it. So for detaching node, first once we detach it node, then what we will do, we will attach that node in the front. This is only we have to detach node from middle and then attach that node into the front. That's it. So now this is most recently used, this is front, and this is least recently used, this is last. And now we have to see how we can detach a node from a linked list. So here you can see in the get function, first of all, since the get has been performed on an already existing key, then we have to first detach that node from that particular node linked list and move it to the front, attach that node to the front. And after performing this operation, now we can ensure that the key on which a recipient get operation performed has been moved to the front of our that support double linked list data structure. Okay, and then we can return node value comfortably. So I will go through the detach node code. So how I am detaching that node. So simply, if node is null, then return. If now second case is Suppose you want to return a detach a node, but node is a single node only present, means front and rear are pointing to same node. Then this node is is already a kind of detached node. So what we have to do, we have to just make this front and rear equal to null and return, because then we have detached the node. And simply we have to make front and rear null, and now the node has been detached. And what if a uh, node is a node has no node has some previous node previous not equal to nulls, means what is if node has some previous node. So this node has one pointer, prep pointer, previous pointer, and one it has next pointer. So this node also has one next pointer which is pointing to this previous pointer, and this node has previous pointer which is pointing to this next pointer in doubly linked list. So what we are saying, if node previous not equal to null, means if node previous not equal to null means there is some node, means this node is not a front node and we want to detach this node, then what we have to do is simple. Node previous next equal to node next, means since we want to detach this node, and suppose there is some structure something, so if we want to detach this node, then this node previous next equal to node next, means we are moving this pointer to here. If there is some previous node to our current node, then we will move the next pointer of that previous node to the next node of our node. So this is how we are doing this. And simply saying, if a node has no previous node, then this is our front node, also our front node. And if we want to detach our front node, then we have to move this front pointer from here to here. That's it. We want to move this front pointer from here to here. Okay. And now if again, if node also has some back node, next node, then we have to also detach node from this side. To detach node from this side, what we are doing, node next previous equal to node previous, means we are doing this, keep previous of this node should goes to next of this node, previous of this node should goes to previous of this node, means previous of this node should go to previous of this node. So we are pointing this to here. So this is how we are detaching this node from here. That's already we are writing here. And if suppose there is no back node, means this node itself is a rear node, then we have to move rear to this because we are detaching this node. So this is why we saying rear equal to node previous, means suppose if there no back node and we have to detach this node, then make rear a previous of this node. And this is how we are detaching a whole node. And now after detaching a node, what happens, these two nodes will connect it, and our this node has been completely detached, and this node is now here with complete detached position. Now we can make all pointers of this null. This previous pointer is also null, and its next pointer is also null. We have moved this node to this here. After that we have to attach that node to the front. So we can see the code for attached node at front. In simple cases, suppose you want to attach a node to some linked list. You have given a friend pointer and you have given a one node and you want to attach it to the front of this node. So what we will do, if node is null, then return simply. If front is null, then front equal to node and rear equal to front. Means if front is also a null, then just itself a front and this node is also a rear node. This is how just insert. If there is one only first node, it is first node. But if it is not a first node, it is a second or third or any node, then what we have to do? We have to make a next pointer of this node pointing to first and a front previous equal to node. Means since this is pointing to the front, so we have to also make a previous pointer of this node to this. Then front is equal to node. Then we simply make this node as a front. So this is how we attach this node to the front. So this is now clear. Key first, if any middle node, if a get operation or set operation is performed, then what we will do, we will detach that node from there. Okay, commit outside make, and then we attach that node in the front of this linked list. So this is how get operation has been performed. Now we have to see a set operation. So in set operation, you have given key, you have given a value, and now node pointer. First we will see key in the cache. If key is present in the cache, if a key is not present in the cache, then we will create another node for that key because we have to insert that node. And if max capacity is already a cache size, means since the capacity has max capacity of cache has been reached, then we have to delete a LRU node, least recently used node. So how we should delete a LRU node? So since our rear pointer is pointing to uh, since our rear pointer is pointing to some node which is least recently used, so simply we can erase a rear key from cache and then delete a rear node, and that's it. We have evicted a cache by one. Now we can insert our key inside a cache by cache key equal to node, and then add node at front. Why to add node at front? Because since now this node, a set operation has been performed on this node, so we have to move this node to the front. Okay, that's it. If the key is not present in the cache, then this is all operation. But if the key is already has been present in a cache, then what we have to do? Since key is already in a cache, then and also we want to perform a set operation on that key, then we have to override a value of that key, and after that we have to what we have to do, since a set operation has been performed on a node, so first we have to detach that node from linked list and move that net to the front. And this is how all this code works. Hope it is clear to you. If it is not, then comment out and I will reach to you, and anytime you can comment it and I will try to explain everything in my next video. Hope you like it. Okay, we can submit this too. So let's say you want to submit it. So okay, so we want to submit, so okay, submit it. Okay, you can like and subscribe till then. Okay, so the it is accepted. Correct answer with 1.27. Thank Thanks for watching my video.